Hello, my name is Danilo Urias, and I am the team leader of the Drod.Gt group. And in this video, we will make a short summary about the study carried out for the Simio Shaving Shop. We are going to start by reviewing the 2D model. The stations represented in this model were created based on the data contained in the data file. Through calculations carried out in the R language, it was possible to obtain the representative distributions for the processing time of each station. For example, if they had a norm distribution and uniform distribution, among others. According to the original statement of the project, the factory consists of 4 cells. We use 2 main elements to model the factory. The first are the servers, which represent each of the stations that process and produce the products. Let's start by talking about the servers. Each server is related to a processing time, so to exemplify how those times were established, we need to review the data generated with the R language analysis. These data represent the statistical distributions of each of the products as they pass through the stations. We can see that there are 6 elements that correspond to assemble 1. Here is the mean, its standard deviation, and others. Now here in the model we look for the assemble 1 server. Among its properties we can see a sequence of tasks. These 2 tasks consist of the following. The first one is because in the project statement it was mentioned that each station has a preparation time. The employees must prepare the machines and everything necessary for the station. These times were described in a table. Here we see in the table of the times that are needed to prepare the stations depending on where they are. For example, assemble, curing, drilling. The table specifies the minimum time, the maximum time, and average time. This is used as a triangular distribution. Going back to the case of assemble 1, which is in assemble, its preparation has a minimum of 8, an average of 10, and a maximum time of 12. So the first task assigned in the assemble 1 is precisely that the preparation time. The next task of this server is the process C22D assemble 1. What this process does? First, it verifies what types of products is going to enter the station if it is a product 19, 20, 21. Then it makes a delay, which is basically the distribution that we observe in the generated with our language. As we can see, for each product that arrives at the station, there is a certain distribution. So in the case of the product B22, we establish it as a type in 19 in our model. The product has a mean of 4.34 and the standard deviation of 0.27. These amounts are given in minutes. Then in the delayed information that I mentioned, it can be seen that we have placed that data. We do the same for the other products that pass through the station. This is basically the same for each of the stations that are represented as servers. Each station has exactly the same logic and only their time values change according to the files calculated with RStudio. Now, speaking about other areas of the model, we can mention the quality area. Here all the orders enter. This area is based on the data in the file Salida RQD. In this file you can see similar data as the previous server, and basically the same processes are carried out. Here at the bottom we see this fragment that represents the order. Basically it represents the calculations of money that is being spent to produce. Up there is the arrival of the materials expressed with an arrival in days. Then the server, each order represents one material. As we can see, these are separated. This is because there are local suppliers and non-local suppliers. We can see this configuration in data and then in work schedules. So here we can see the schedules for local reception as well as for non-local reception. On the right side, we can see the orders from the sales area. This order data were extracted from the sales data sheet of the data file. This file contains the date of the order, the product request, the quantity ordered, and the customer. This area works through a server that is responsible for reading the request periodically from the datasheet. After this process, the order advances to the combiner where it is expected to establish it according to the amount of product request by the client until the orders are finally completed and leave to the delivery area. This is a simple explanation of the generation model. And now let's see the 3D model. It is based on the model that we reviewed a moment ago. As we can see, it has exactly the same sections and the same for cells, but it gives a clear idea of what of a way in which they behave. The elements they make up the factory a moment ago in the 2D model, only a small representations were observed. Here we notice that the stations already appear in a more representative and understandable way. For example, in the frame assembly cell, we note that there are the curing stations, the screwing area, and the respective employees of each area carrying the products. This model allows us to observe the behavior from different perspectives and give us a clearer idea about the operations of the model and if it were reality. Observing the results of the articles produced, it can be mentioned that the simulation model produced from 490 to 500 final products in 5 working days, and that the articles produced did not meet the customer's demand for the products. On very few occasions, the filling rate reaches over 19% of the demand. In the semi-shelving shop factory, throughput is defined as the number of shelves completed per unit of time. Considering a week of work, the following performance results were obtained. From this result, it's possible to conclude that the current performance is regular and at no time is 100% performance achieved to the able to complete all the request orders. Based on the study carried out and the observations of the behavior of each of the stations and buffers that make up the factory, it is recommended to modify some of the stations, increasing the machinery and the employees necessary to operate them. According to the recommendation of an expert, it is necessary to implement a dynamic inventory. With this dynamic inventory plan, it would be necessary to identify the materials for which a buffer will be implemented. For this specific case, it is recommended to duplicate the units in each of the elements, especially for the activities of assembling, sanding, painting, and the unification of products. It is recommended to make an improvement in these areas because it was evidenced that the products process is currently carried out in an inefficient way. Following the DDMRP system, the following recommendation would be to create a correct resizing of buffers or inventories. This would have the purpose that we supply of products and be expanded or reduced. This resizing should be carried out with respect to the real daily demand. Obviously, it would not be enough with the establishment of a dynamic inventories. It would be necessary a daily production planning that allows to establish the adequate quantities for manufacturing. Additionally, it is recommended to implement an early warning system that allows recognizing problems with sufficient time in advance to be able to take measures that maintain the good performance of the system. This has been our presentation. Thanks for your attention.